What's up, guys? How are you doing? I hope you're great. My name is Jesse, and welcome to part 2 of this tutorial, where we are going to continue to do semi-automatic object-based image analysis in QuantumGIS. So this is a continuation of the first tutorial. Before you proceed with this tutorial to have such a nice output, I want you to first watch the first tutorial and then install the dependencies. After installing the dependencies, install the plugin, and then you can proceed to this tutorial. Let us continue into our second tutorial. So this is the plugin that we've been able to install. It has a GUI like this. It has a model, the input layer, resolution, number of segments. So what is the model? The model is the model that is going to be used to do our segmentation. And we have two options here. We have the k-means and the convolutional neural networks. However, if you want to use the convolutional neural networks, you have to write an email to sales@quantcivil.ai. But if you want to use the KNN, it is free of charge. So I'll use the k-means The k-means model. So the input layer, it has to be my image color, and then the resolution of this image. It is a very high resolution image. Look at it. It is a Google satellite image. Look at it. So, and then the number of segments. The number of segments is the same as the number of classes you want this image to be broken down into. So I will put 5. So it is saying, please input key with dashes if you want to use what? With CNN. But me, I don't have the license. So I will just click what? Segment. But when I click segment, it brings an error. Oh, sorry. But I did this step intentionally to show you that you don't have to segment any sized image within this plugin. You instead have to have a particular size of images that you have to do what? To work with. So to do that, I have already a code I wrote in Python. Actually, I did not write it by myself. I wrote it with the help of ChatGPT. It's here, which helps you to slice your image into equal slices. Why am I doing it outside QuantumGIS? That is the question you may ask. Because if I do it within QuantumGIS, I will not be able to have equal sized slices. So with this code of mine that I have, I introduce a concept called padding, which will add a white background to an area which is less than the tile size. Let me demonstrate it here. Now, this is my image. So I'm going to extract tiles of 1024 by 1024 pixels. So to do that, I will click export, save as, then I'll click VRT, and then I'll come here to the resolution. Then the maximum columns, I'm going to have 1024 by 1024. So I'll say create VRT, then I'll select where to save my slices, and then I'll click new folder, and then I'll say demonstrate slices. I want to demonstrate something. So when I select this, I click OK, then I click OK. So it will do what? It will slice my image. So let me check the results. To check the results, I will come here to demonstrate, and then I add the results. Layer, add layer, raster layer. Then I click demonstrate, open, and close. So I've been able to have 3 slices, as you see. This is the first one, the second one, the third one, the fourth one, and then there are 4. 1, 2, 3, 4, but they don't have equal sizes. So what do I have to do to make sure that they have equal sizes? I must introduce a concept which is known as padding. Let me demonstrate this. So this is my what? My slice. To make it 1024, let me see. It is 1024. I will need to add an area here, an area here, and an area here. Let me hope that it's okay. Let me say it again. I will need to add here, here, and here to make it 1024 by 1024. Or I can even add below it here, here, and here to make it 1024. I hope that is okay. Sure. So to do that, I have already written some code with the help of ChatGPT. The code is here. That will help us to slice our image into equal tiles. So I've shared this code with you. So if you want to use this code, just check the description of the video and then download it. So to use this code, you have to change two things. The input file is the file where you have your what? Your image. So let me show you where to put it. So this is the code I've given you, and then I have another folder called image. Within this folder I have an image called image Kampala. So it is the one here. My input file is image. Now within image I have image Kampala.tif. Then my output folder, let me call it, can I call it slice? Yes, let me call it slice here. Slice. So I will click save as padding.py. Then I click save. Then I will minimize this. So to run this code, I will come here and then I search for OS Geo4W shell and then I'll enter. When I enter, I will come back here again to where I have my source code or my Python file, and I'll copy the directory. Then I click CD and then I paste the directory and I'll click enter. So after clicking enter, I'll actually type in Python space, then I will run my Python my Python file. You see, slice with padding.py. So before I run this Python file, I've told you that I'm going to create slices which are 1024 by 1024 size. So if you want to change the size of your slices, you can change it from here. I hope that is fine. You can put any number you want, but not any number, but a number which the deep learning model can work with. Maybe 512, 102, and so forth and so forth. So after this step, I will click enter and then I will run my my code. Of course, it takes some time to run, but then after there, it has run, and then I'm going to check the results. So to check the results, I'll come here, then I'll click slice. So this is what I was telling you. To have equal slices, I have to create empty cells. These are white empty cells, 1024 by 1024. Why? So with this size, I can be able to do inference on my satellite image, unlike the smaller one, which was passing where? Which was passing here. I hope that is okay. So after that step, I will input my slices into my QGIS. So I click layer, add raster layer, and then I will browse to where I have my slices. Then I will put the first slice, the second, third, and the fourth. Open, and then add. So these are my slices. I have the first, the second, the third, and the fourth. Of course, you cannot see the white because of my background here, but I want to assure you the white pixels are there. They are there. So without wasting time, I'm going to work on my first slice. I'll click here. When I click here, it will bring for me the options. Still, I'll select k-means. And then the slice is the first slice. The resolution is very high. The segments are 6. Then I'll click segment. So when I click segment, it will give me a segment. Are you seeing the segment? It has 5 classes. So what I can do, I click to properties, then symbology, I will click unique values. Then when I click unique values, I'll click classify and I click apply and then I click OK. So at this stage, I can be able to look and then compare with the true color image, and then I'll be able to select my what? My classes. So when you click here, the segments, you can put any segments you want. You can put 8, you can put 12, and then from those segments you can get the land cover what? The land cover classes. So feel free to play around with the resolution from high to medium and then to low, and then you see what? The results. So at this stage, I'm going to click this. You see this icon. When I click it, it will enable me to update my symbology on the fly. Look at what I'm meaning. So from what I've seen, this purple is trees. So I will select it. And then this other green, this light green, I can give it this color. Oh, no, this color is not good. Maybe this color. Sure. But before, let me reduce the opacity of this layer. Let me reduce the opacity. I need to reduce the opacity of this layer. Let me make it 70, something like that. Yeah. So let me see. This is green. Yes. And then this one, let me look for this color. I can call it this brown. Yes. And then I can call this red. Perfect. So that is my what? My results. So, but remember this is a raster. So let me also do some inference on another image. So I'm going to do inference on this image, this one. So still I'll select 5. I'll select it here. And then instead of selecting 5 classes, I'm going to select 6 because I have a background. And then the rest I'll leave as default. And then I will click segment. So after clicking segment, I will look at it here. This is my result. Then I will click properties. Actually, I will use the same approach I used here. I click this and then I will click unique values, classify, and then apply. But as you see, the 0 is a background, so I think I can remove it. Then I leave the others. So This one I can give it a red color, and then this one, this blue, let me have a look at it. Okay, this can give it this color, and then this, so I can give this color, and then I can also give this color, something like this. So since this is for demonstration, I will stop here. Then I can add the first one, sure, something like this, but still I can work upon its opacity to make it something like 70. So let me see, so something like this. So at this stage, I'm going to do the most crucial step at this moment, is to convert this raster into what? Into segments. So to do that, I'll go to raster, extraction, rather conversion, then I'll click raster to vector. Then when I click raster to vector, I want to click this. I'll select this slice 0, this one. Of course, I'll use this band. Then I will use the DN. Then the rest I'll leave them as default. I can save it to my file as segments. Can call it segments, and then I run. So at this stage, let me just remove this. I will come to properties. Actually, let me not use properties. I'll just come here. I click here on the fly, and then I click categorized, classify. Now when I click classify, the value is the DN. Classify, it will give me 4 classes. But before, I will come here, then I will look at the stroke. I will make it 0.0. Yes, that is okay. Then I will come back. So the first class, which is 0, for me is 0. Let me actually start from the 1, because the 1 corresponds with this. Then after the 1, this green corresponds with the roads. Now this also corresponds with the build-up. Okay. Now this, what is this blue? This blue corresponds with, this color is too bright, it's too shouting. Let me try to get another color. Yes. Then actually let me just copy it here, and then I can paste it somewhere here. So something like that. Then, of course, me, I've not been keen enough on the classes. I'm just demonstrating. But I hope when you are doing your classification, when you're doing your analysis, you should be specific on the classes on your image. Which classes are you looking at? What classes are you considering? Which class to include, what class to exclude? I hope that is okay. So you come to vector here, you come to geoprocessing, then you come to dissolve. When you click dissolve, you select the vector data. Then the dissolve fields, I will select the DN that I want to dissolve. Then I will come here to advanced options, and then I'll say skip, ignore features with invalid what? Geometries. And then I will run. After saving, of course, we are to put my what? My dissolve. It takes some time depending on how big or how small this image is or this classification is. So after it finishes dissolving, what I'm going to do is that I will click here, styles, copy styles, symbology, and then I will just paste the same what? Symbology here. So after that stage, I will come and I open the attribute table, and then I will come here, and then I will compute my what? My areas. Penfield calculator, and then I'll say area. You can use a decimal. I'll say the area. So that is area. I will click. Okay, so that is my area. So in case you have any question, just write to me through my email, jesebingo48@gmail.com. Don't forget to subscribe to this channel and then hit that what? That like button. Thank you.